Welcome back. Today we're going to take a look at how to build a multiplayer time of day system, and we're going to go a step further and make it synced up between all of our servers, which is important because we're switching zones. Potentially these zones could be on different hardware devices, and you don't want it so that, it's daytime on one and then you transfer across the other zone and it's nighttime. So we've got to sync them all together, and I'm going to show you a much more efficient way of doing multiplayer day-night than what you normally see. It's a lot simpler and a lot more efficient than what you're going to see in other videos. Okay, first thing we got to do is we got to download the latest plugin. It is the 2018 10.7 version. So, as we normally do, I've downloaded it. We're going to go into our plugins folder, dump OWS plugin, come back here. We'll navigate to the OWS plugin, copy, back to here, back to plugins, and paste. Okay, we'll let this finish here. I'll actually show you the wrong way to do it. So the wrong way to do it is to use a timeline. Don't use a timeline. Timelines are bad. Timelines are like really nasty tick events. Just don't use them in blueprints. There's too many reasons not to. And in this case, it's particularly bad because it also sends multiple replicated values. And there's no reason for us to replicate these values when we can just replicate a time sync. So this is the bad way to do it. We're going to do it better. Oh, thought it'd be done by now. My SSD is starting to get full. Have to clean out some junk. All this Paragon content is just so big. Okay, so now we're going to load up the project with the new plugin. We're gonna do a lot of fun stuff here. We're going to create curves for the cloud opacity, curves for the fog density, curves for the sun intensity. We're going to create our own BP sky sphere, and we're going to modify the color curves as well. So let's get started. We're going to need a lot of assets here, so let's make a new folder for time of day. Okay, first thing we want to do is we want to make our own BP sky sphere. So we've got this BP sky sphere here, and let's see. I'm trying to think the easiest way to find. Is there a find? Yeah, browse to asset. Okay, so what that also did is that just hit this show engine content. If you didn't have it on, that usually turns it on automatically. We're going to turn it off when we're done because I don't particularly like that. But the reason that I did this is because I want to grab the cloud color, the horizon color, and the zenith color, and I want to duplicate them. Then I want to grab those duplicated ones, and we'll scroll back up to our time of day and move them here. And then I usually don't leave engine content on, so I'm going to turn that off just to clean it up a little bit. So we now have our own versions of this. Let's go to create a blueprint, and we're going to inherit from BP sky sphere. And we'll call it R sky BP. Okay. Take a look at this real quick, and I'll show you the stuff we're interested. We're interested in these color curves. So the default color curves, they basically leave the sky orange for 10 hours. Now, I don't know anywhere on Earth that that's the way it happens, but to me it looks terrible. So we're going to go in. We're going to go in and modify all of those, which is probably what we should start with. So let's start out with the cloud color 2. And this isn't exact, but I came up with some numbers that I kind of liked. And here's what I did. I grabbed these, and I pulled them down. I grabbed these, and I slid them this way and down. Right up to about there. And I took these, and I slid them to about here. Anyway, you can play around with those to get better numbers, but I found that to be, made me pretty happy. Next one we're going to do is the horizon color. Okay, I took these and I moved them. I want a blacker night. We're going for a dark night, so you may not want to go as far if you're not into, you know, completely dark at night, but that's what we're going for. And I think I slid these right up to about there. And then I took 3, 8. I took all of these and I slid them at about there. Again, these are things you can fine-tune to get just the right look. I only spent about an hour playing with them, trying to get them to line up. They're pretty good. It's a good starting point. So I was happy with that. I took these and I took all of those and I pulled them in this area. And then 0.38. I guess I left this. I was pretty happy with that. Okay, so now I've got those. Now we're going to go into our sky sphere that we have overridden, and we're going to pick the 2 versions. So horizon color 2, zenith color 2, and cloud color 2. Okay. Then we're going to dump our sky sphere. I selected it over here and hit the delete key. We're going to drop in a new one, and we're going to connect it up to the sun. I don't think we had any other custom settings, so we should be good. Okay, so now we've done that. So now it's time for us to create a new blueprint of type actor, and I'm going to call it better time of day BP. Okay, and we're going to drop one of those out in the world. Okay, so we got to do a lot of stuff here. Get ready to build some blueprints. Okay, we're going to have a slight delay here before we pick up the references. And we need to create some references here. So, here we go. Variable, sky sphere of type R sky BP. Okay, next variable, sun of type directional light. Creating references, we're going to grab all of these on begin play so that we can manipulate them. Variable, sky light. Skylight reference. Sun intensity curve. This one's weird. It should be called a float curve, but it's called a curve float. Took me a while to figure that one out. And we've got fog density curve. Also of type curve float. and a cloud opacity curve. Also of type curve float. And now we've got some floats. So we've got seconds per day cycle of type float. And this one's actually going to be made public, so we can control it on the instance of the BP. We're going to need some internal ones. Offset seconds, percent day complete, test start offset. Remember, in the future that one can only have positive numbers. For some reason it doesn't work with negative, but this is a good way for testing if you want to start at a certain time of day. I threw that in there. And now we've got some replicated ones. So we've got time sync. And we're going to go over here to replicated. And this one is a rep notify, so that it creates this on-rep time sync. We'll take a look at that in a bit. And I want to put this in a category just to make it easier to find. So it's going to be up in this replicated. You can put in categories, type them in, and help organize a little better. I'm not huge on organization, but I was having trouble finding the replicated ones. And unfortunately, there's nothing on this list that shows which are which. It can get confusing. And the final one, current world time at start. This is the one that's going to sync us across servers. This one's also going to be in the replicated category, and this one, regular old replication, is good enough. Okay, now we got our things to play with. So here we go. Get all actors of class. Should only be one. We're going to actually, we know that one exists, but we're actually going to do this the right way. Or we're going to actually verify that something exists before we try to access it. Probably isn't necessary in this case, but it's good to get into a good habit. Anytime you use a reference, anytime you get an actor to class, make sure something exists. BP SkySphere, actually in our case, it's actually going to be R SkySphere, SkyBP. So we're making sure that there's more than 0 in that array. And then if there is, now this one really bothers me. So this says get a copy, and if you read what it says that a copy and the changes won't propagate back. It's actually confusing here. It's telling you the changes won't propagate back to the array, but it actually is not a copy. This is actually a reference. So that one can be a little confusing, but don't worry, it's a reference. And then if that's correct, we're going to set our SkySphere to this value. And we're also going to, always good to add print strings. Blueprints are hard enough to debug as it is. Put print strings on any path that you think something shouldn't take. Never leave empty paths. This will just make it easier. Find our SkyBP. To make it easier to troubleshoot in the future. It's just one of the things that you learn when you realize that most of your time working with BPs is spent tracking down simple mistakes. Which is actually normal for all programming, but it just seems especially to be the case when it comes to BPs. Okay, the next one we're interested in finding is the directional light. So keep in mind these things will only work if there is one of them. Otherwise you're going to have to use other ways to find the specific one you're interested in. But in our case there's only one directional light, only one skylight, and only one RSkyBP. So we're good enough to do this. We're going to do the same thing again. Check the length. Is it greater than 0? I need to clean out the light on the bottom of my mouse. Not getting a really accurate movement. Okay. Slide that back over here. We'll get 0. Again, this is not a copy. It's actually a reference. And we will set our sun. Again, on the false. Print string. Can't find directional lights. just let us know if something's not working. This will likely be the reason why. And to get all actors of class. And this time we're interested in our skylight. Again, check the length. Is it greater than 0? If so, we're good to go. And we'll set the skylight. Do a get. It's a reference, not a copy. On failure, print string. Can't find skylight. Oh! Got another one we missed somehow. Missed one. Bummer. Okay, let's come back over here to variables. And we're adding a height fog. And it's of type exponential height fog. It's a bummer, because I wish it was up with those, but whatever. We should probably organize it better. Okay, let's grab get all actors of class. And we're looking for exponential height fog. Same thing. Length. As many times as I did this, I felt like writing a C++ template function called get first actor of class. And then some nice fail here on the length and check and all that in one. But there's only 4 of them. Just took a minute. Okay, and we're going to set our height fog. And we're going to print string. Get find exponential height fog. I think that's all of them now. Okay, so just for fun here, I'm going to say got time of day resources. So we know it gets here. We would probably know anyway because we'd hit one of those print strings, but okay, and now we're only interested in, we wanted to grab those on both sides, but here we're only interested in the authority, which reminds me that we forgot something, so let's do it right now. Class defaults. We need to come here and we make it always relevant. This is super important. Took me a while to figure this one out. It's not always relevant. You will have problems on large maps. And we also want it to replicate, but we don't need to replicate the movement. Okay, so now we're on the authority side. We're only on server side. And at this point, we're going to get the time sync. But we haven't added this yet, but so we're going to get the game mode. We're going to cast to third-person game mode. We'll right-click and change this to a pure cast. We know it's going to be that game mode because there's no other game mode. And here's where we're going to need to pull off a value, but we don't have it yet. So let's go to our third-person game mode. And we need to work on building our time syncing between servers. So third-person game mode. And what we want to do is we want to come here to the end here where it does this global data thing. This is just a test showing you it. So we could kill this, right? We don't need this. So let's dump it. So we're going to delete that. It was just kind of in the OWS thing to show people how things work. And instead we're going to use this new node, get current world time. If you didn't update the new plugin, you don't have this. So, and we'll do event, if I could spell, notify, get current world time, and as always, err, get current world time in case there's a problem. This will help us find that problem. And what we want to do is we want to create, we already have one actually, set local seconds offset. This is in the underlying game mode in C++. It's also new. So we grab that and put it in this value. So this is going to get, at the start of when the game mode spins up on the server side here, it is going to time sync to the servers using this get current world time. We'll talk a little bit about that more, but now we're going to go back here and we're going to get local seconds offset. And we're going to set this replicated value. And we're only doing this on the authority side. And that's going to replicate back to all the clients. By doing this, it's important, by doing this replicated variable and not a multicast, this is going to make sure that people who log on later, which everybody is because this is when the game starts up, when they log on, this value will get replicated to them. It basically creates a queue and all these get replicated. It's very important to use that for state. Set timer by event. And we can play around with the values. This is for the time sync. 1 second's probably too often. So we can play around with lowering that potentially. I'll talk a little bit later about how you optimize this per your cycle. Everybody's cycle is going to be different. So we're going to custom event update time sync. And what we're going to do is we're going to get real time seconds. This one works whether it's paused or not, so don't use the other seconds that are paused because basically you can't pause an MMO. Set and time sync. So we're going to set the time sync. And this is going to end up calling the rep notify on all the connected clients. It will also get sent to someone when they log in, which is a plus. So we're going to go to this on rep time sync. And what we do here is we're going to end up setting our local offset seconds. And we're going to use the time sync value. But then we're also going to subtract the time on this server. Get real time seconds. So we're basically just saying, hey, what's the difference between our servers? One of the good things too is when you deploy this in prod, most prod servers actually run, every server I've ever run, it connects to a time service to make sure they stay in sync. So you usually can calculate on real servers to stay in sync, which is the reason that you can actually take that time sync and not have to do it every second like I'm doing it. So this is overkill based on the fact that maybe your local clock doesn't work. But if you deploy this in the cloud, Azure, AWS, those things are time synced. They're very accurate. Okay, and that looks good. So now, what we want to do is we want to come over to our tick event and say, what do we do? Now, tick events are normally not a good idea, but I'm going to show you how in this case we can make them a great idea. So the reason that tick events are frowned upon is they run too often. So normally, by default, the tick interval is set to 0, which ticks every frame. Bad. In this case, we're going to we can play with these numbers, but we're going to start at 1 second. Now, this is something that we'll end up optimizing based on how long your cycle is, and I'll show you a little bit about how we can do that. But first, we need to build %day complete. Everything else runs off this. We're only interested in the client side. Okay, so we're going to work backwards. Divided by. We're going to divide by seconds per day cycle. And then we're interested in a modulus operator. modulus gets you the remainder of a division problem. And again, we're interested in seconds per day cycle. And in this one, we're going to create a few numbers that we add together, actually 4. So we want get real-time seconds is the first one. And then we will add to that our local offset seconds so that we now match the server. This could be negative. And then we will add our test start offset. This is just for testing. This thing does not work when it's negative, so this one's a problem. It actually goes too far back in time, and it ends up going outside of the repeatable curve range. And the final thing is our get current world time at start. This will sync it across servers. So when we put all those together, we now have something that is accurately synced into our percent day complete. Okay, now all the things we're going to use it for. So, is valid checks. Oop, I want the macro. Is valid. So, we want to make sure, did we get a sun? This is just to stop error messages when something screws up. No, I didn't want that. Sky sphere, get is valid. Okay. So now what we're interested is we want to grab the sun and we want to say set actor rotation. We're just going to do a simple straight over the top rotation here, but we could in the future expand this like we do in our game to also handle the time of year and different cycles rather than, but this is just going to be straight over the top. We're keeping it simple for the demo. Yeah, put that up there. Okay, the only one we're interested in is, okay, so we're going to multiply by 360 to get it into degrees. And then also, I really didn't like where it started at, so I'm going to put in a 180 offset. You don't have to do that. You could just build your curves that we're going to build here in a second a little different than what I do. But I was pretty happy with how that worked out. Okay, next up we've got our sun. And we're going to set intensity. And it's on the light component, so it'll grab that. Okay, here's where we're going to grab our sun intensity curve, which we haven't built yet, but we're going to. And we're going to say get float value. In a way, this is like using the timeline, but this method is much better, as we got around that nasty tick built into the timeline, which is what makes it so bad. And instead we're ticking once per second, which is awesome. And we'll grab percent day complete, and since that is a percent, times it by, I don't know why some of these defaults can't be the default. 24. We'll be doing that every time. Percent day completes always gets timed by whatever your hour cycle is. You might make it different in your game, and that's fine. Okay, and then we're going to grab our sky sphere and update sun direction. This will make our changes visible. Okay, here we're going to use a fun little trick. This may not be the best, but sometimes blueprints are meant to be abused. And so we're going to use a flip-flop. And you might be like, what? And we're only going to connect it on A. And so what actually happens is it says that everything on the right side happens once for every 2 times it happens on the left side. The reason we're doing this is we're going to get into some more expensive things that don't need to be changed every second. So this gets done every second. this gets done every 2 seconds, and our final flip-flop will get done every 4 seconds. There's other ways you could build that, but this is a nice, easy way for the demo. Okay, we're going to grab our height fog, and we're going to set fog density. And again, we're going to grab the fog density curve. We're going to get float value. We're going to use the percent complete times 24, so I'm going to go over here and copy this. So this is the lookup that it's checking in the time of the curve. And we're going to go build those curves in a minute. And then we need to set sky sphere, set cloud opacity. We do the same thing. Cloud opacity curve. Get float value. We're looking up the value in the curve based on the in time, and it uses the same percent day complete times 24. You could have done your day complete as a 24 cycle and gotten rid of that, but I'm just really used to things being 0 to 1 with floats. It's just a good system. It's just always make any kind of progress from 0 to 1. Okay, we're going to do another flip-flop because this final one is pretty pricey. So we want it to only happen every 4 seconds. And this is it's also not super noticeable, usually. This is the recapture sky. And if you look at that, there's a warning on it. This is very costly and will definitely cause a hitch. Potentially this could be problematic on really slow hardware. I ran it on a 460, GTX 460 with a computer from 2010. And it hit hard, but it wasn't enough to ruin the game. On a 7800K with the 1080 GTX, it's barely a blip. So that one's got to be careful about that one, but it's kind of needed if you're going to run time a day. But again, do it less often, maybe even not every 4 seconds, maybe even more than that. So, however, remember this is a fourth, this is a half, and this is 1 to 1, and we can change all of them by coming over here and changing the stick interval. So you don't actually have to control them all individually unless you need that kind of control, in which case replace these flip-flops with different timing systems, and you can do that. I think we're good here. What we're missing now is our curves. So we see we've got the sun intensity curve, fog density curve, and cloud opacity curve. Also, we have another problem. We don't even have a height fog. Move some of these up into lighting so they're easier for us to find. You can just move to lighting, because this thing doesn't scroll when you drag up. But we need an exponential height fog. And we are going to turn on... Okay, we're going to actually come down here and turn on volumetric fog. Just check these settings here real quick. We'll start the fog density at 0. It's going to be controlled by the curve anyway, so it probably doesn't matter. Really just the flash in at the start. And okay, we want to go down here, override light colors. Okay, so those colors are now going to get pulled from the directional lights. And make sure the rest of the settings are good. Yep, so we're going to go to the sun. And we need to, it told us that we had to make sure that the atmospheric value was turned on. So let's find that one. So we had to do the down on the light section, and it's atmospheric fog sun. That has to be on. turn those on. Okay, and now it's curve time. So let's go back to our time of day, and we're going to need to create some curves. And the first curve we're going to create is, let's see, I think it's under miscellaneous. Curve. We're going to call it, we're going to do a curve float. That was the type we chose, and sun intensity. Okay, pretty simple here. Add a key at 0, 0. I found that it helps here to have a little bit of a shoulder on this, and so we're going to create another key at 0.20. Then the next key is going to be at 510. 510. And the one after that is going to be at 710, or this is the sun intensity. And the last one is going to be at 11.8. Remember we did 0.2 here, so we're going to do a shoulder back at 11.8. 11.8 and 0. I don't know why those fit horizontal and vertical don't work. It makes no sense to me. Anyway, this is a 24-hour curve, so that's basically the curve. Okay, and so we can come back here and sun intensity, plug it in. Okay, next curve that we need to create is going to be our cloud opacity. Curve float, cloud opacity. And this one worked pretty good without a shoulder. So we're going to do 0, 0. And I found it was pretty good to go up to 0.7. So we're going to do 5, 0.7. Going to add one at 7.7. They really could have made this easier to edit. Okay, and the final one will be at 12.0. And you may have to play around with these slightly just to get the look you're going for. Getting them all to line up nicely. I did pretty good, but there's still a little room for improvement. Okay, and we'll select our cloud opacity. And the last one is fog density. So we create a curve of type curve float and fog density. Okay, this one was a bit more fun. I did play around with this for about an hour, and I was pretty happy with the results, but the reason I played with it so much is because there were things about it I didn't like. Okay, and this time I'm going to actually set this to auto and get a curve going. Okay, smooth curve. The second one is 1.01. And the next one is 6.5. 6.5 and 0.002. And then finally, yep, we got a couple more. And then we're going to do 12.01 and 13.5 at 0. 13.5 at 0. And then 22.50. And then our final one will be 23.5. 23.5.08. Now the fun part. There we go. Okay, going through and we're going to set all these to auto. A little smoother curve. Right click on these and choose how they curve. Pretty happy with that one. Okay, these we can't have it go negative. So we got to adjust this until it's flat. I really just want that flat. That's good enough. Pretty happy with that one. This one here is problematic. We don't want this to dip down. So something like that should work. Yeah, not bad. And we'll go in here and we'll set the fog density. Okay. I feel like we're close to trying it out. So I'll load in our levels here. Think about if we forgot anything. Okay, we got a couple things we want to look at. So we're going to select our better time of day BP. The seconds per day cycle, just for the first test, I'm going to set it to 24. It means 1 second an hour. And I think that's all I had to set, but I'm going to double check the defaults. Nope. 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 Okay. So we want to make sure we have one player. And we'll make sure our output log's open and clear. We'll hit play. Oh, man. I have not gotten an error in a long time. Let's see what it could be. Yeah, it's probably been a couple months since I got in a Clash to Desktop. Used to get it a couple times an hour, but it's been a while. See if it's something repeatable. Potentially calling underneath to the server. Potentially something calling underneath to the plugin. I did try it in the test project pretty much the exact same way, so be surprised if that's what it is. Very interesting. That's not going to be fun. Let's go back and try to troubleshoot it. It's always crazy when you do something in one project and it works fine, and you do it in the other and it doesn't. Let me think here. Is there anything else we changed? Nope. That's pretty much it. Okay. Well, let's get to see a little bit of how I troubleshoot here. So first of all, we're going to pull out that time of day BP just in case that's what's causing the issue. And we're going to hit play. Yeah, as I suspected. It's probably what we're making our call in our game mode. Which I did do slightly different. I did do slightly different than what I did in the other project. But let's go and disconnect that, just in case that's the issue. Aha, it was. Well, that's not a good sign. Okay. So it does not like Does not like this call here. Get current world time, which is new. And I'm just going to go back and make sure that I did have the right plugin version here. Okay. Interesting. Okay. Let's current world time, local seconds offset. That's a value that's already there in the game mode. So it would already be adjusted or be replicated. Okay. Just for fun, because I want to get back to desktop anyway. Usually this isn't the way you get back to desktop. Okay, good to know. So what we're going to do is, and I'll fix this, probably the plugin that I uploaded probably has a problem. So I will, I'll go fix that before I post this. Will be good. But what I'm going to do here is I'm going to come and dump this plugin. I'm going to go pull the one that I know works from the copy. Should, in theory, be the same one. But this is a good way to rule out that that's not the issue. Okay. And so now let's load this one up. Did I copy the right place? Yes. So now we know if it works, that I got a problem with the plugin I uploaded, which I'm not sure how that happened, but I will fix it before the video is uploaded. If that is in fact the case, and not something else going on here. Come into this game mode, we're going to reconnect this. That is not the issue. Very interesting. Okay, well I am going to I'm going to stop the thing here, and I'm going to troubleshoot it, and I'll be back. Okay, that was quick. It took me about a minute. But remember I said that I did something slightly different here than I did in my test project. And in my test project, I left this. Now we've already deleted this earlier, so I'm going to sit here for a second and show you what you can add back. So these 3 nodes I had deleted, and in the test project I had not, and it does not like those removed. So let's add these back. This test key, test value. We'll come back and fix this later at some point. But the reason that it did this is that this actually served as a delay, and so this was getting called too early. So we could potentially fix this by doing a delay or moving this to another place, not the begin play that's after it. But actually this ended up fixing the issue just because this is an instant, and so it delayed the running of this. And as you can see now, we don't get any crashes to desktop. So I'll look into it a little bit more, see if we can make that a little more stable, but without having to delay. But it's basically an issue of things running too quickly. So we're going to come back here, load back up the world, and I'm going to add our better time of day back to the world. And we're going to go back here and set it to 24 cycle again. And we're going to go to output log, clear log, and play. Okay. Take a look and see if the sun is moving. It is not. That is not ideal. So we're going to have to figure out why. Look at our output log. Got time of day resources. That's a good sign. Okay, so we were able to get there on the client, and the server's probably up higher. There it is, server. Get time of day resources. So that looks good. This looks good. So we're making it to here, and then this runs on the authority. Just make sure not messing anything up. We're getting the local seconds, putting it here. We have a timer by event for 1 second, and it's looping. And it sets the time sync. Looks good. That calls the onRep notify. That looks good. Back to the event graph. Our event tick. Ah, look at this. Look at what happened. Bad, bad. So because of where I had dropped those up higher, I must have connected it to authority when I didn't want to. So that would be what happened there. Let's clear our log. I can see it running through the cycle. So we'll just sit here and watch it. And you see the red doesn't stay nearly as long as normal. This is moving way too fast at 24, so can't really judge the smoothness of it at this point. We'll take a look at that in a minute. Yeah, look at how fast all that fog and everything appeared. A little too big. So let's go in here, and one of the numbers that I like to test with, it's not great, but it's 120. Obviously, you would never actually have it move this quick, and I'll show you in a minute some production numbers, but this is one that I use that works pretty good for testing. You can see a little bit better how it's moving. You can see the fog dies away as the sun rises. The cloud opacity starts to get stronger. Midday as things heat up. Moving over top. So one of the things that you watch for is how fast those shadows are moving. Obviously that's not good, but again, we wouldn't actually use 120. We would use something different. And something we're going to test here real quick. So you see where the sun is in the sky. I'm going to stop. Okay. Now it's keep playing, right? Because we're getting the world time from the server. So it keeps playing while I'm not playing. And this is how it syncs between the servers. And there we go. It's back. It had just gone over the edge. No, it had not. Aha! Found another error. You see that? It actually started up from the beginning again rather than syncing where it should have been. So see where it is in the sky? We should now play, and it should go back to that same spot in the sky. Wow, we got some really weird stuff going on here. Okay. Let's do a little bit of troubleshooting. So, where that comes from to begin with is the game mode. Gets our value and puts it in local seconds offset. And that is what we want to do, put the current world time there. Okay, so now we have our thing here. We got to make sure that we're using it properly. So we're adding our real-time seconds, offset seconds, test start offset, which is 0. The offset seconds gets calculated. We'll have to go take a look at that. And current world time at start. This is the value that comes from the server. We add them all together. We modulus against them second per day cycle, which gets us the remainder. Then we divide that again to tell us where we are in the current day. And we multiply it by 360, we subtract 180, and we plug it into the rotation. Looks good. Everywhere here, we just to make sure we do a 24 lookup. Looks good. Also a 24 times 24 times 24. Set the fog density. Set the cloud opacity. And finally recapture the sky. Here's where we get the current world time local seconds offset from the game mode on the authority side. That looks good. We then just take the real-time seconds and send it into the time sync. Let's compare our class defaults. Our test start offset is 0. We're always relevant. Net load on client and replicates. Gotta say that looks good to me. Current world time at start. Let's print string that. Let's print string it here. Yeah, we're gonna need something to be able to notice it. Append current world time at start. See what that value looks like coming from the server. And that's when started at the beginning again. Okay. That's starting point is right there. The sun at the horizon. So let's look for current world time at start. Oh, it's pulling in a 0. So that's a problem. Why is it pulling in a 0? Interesting. That does seem to be problematic. Let's make sure again that we're setting everything. We got the game mode. We set it. This is server side. So that's good. That's on server. Gotta remember that. And then we come back and we pull it from the game mode also on the server. But it should not be 0. Just double check that I didn't miss something. Local seconds offset. And current world time start at start, which makes sure that it synchronizes, but it didn't matter. We're not looking at the synchronization anywhere. We're looking at it not being set here. So I would probably say it's going to be an issue down in the code itself. I did have this problem actually when I first did it. I didn't update the server, but in this case I did, and this one's pointed to the same server you guys are pointed to. I have a local one I also run the other project against. So that's not the issue. I'm going to stop the video here again, and I'm going to take a look. I'll be back. Okay, I'm back. It actually was a lot simpler than I thought. Everything's working good in the C++. It's a timing issue. So by us adding back this unknown delay, this value is actually getting set after it's being accessed, and therefore it's 0. So what we're going to do, which I do in some cases here, is we're actually going to come back to this code here. We're going to wait. We know that the value has to be greater than 0. It's impossible for it to be 0 or less than 0 because of how it pulls from the server. So what we're going to do is we're going to basically create a loop. And we're going to say, hey, keep rechecking it because you can't continue. You can't continue until it's non-zero. And I guess we'll keep rechecking it every 0.2 seconds. Probably the first one's good enough. And we're going to create a branch. And we're basically going to say, hey, is the value get current world time at start greater than 0? And if it is, we'll continue. If it isn't, we're going to retry. That looks terribly ugly. I don't normally use reroute nodes, but this may be a case for them. It's going to look bad no matter what we do here. What? Ah! It's got some kind of thing that it knows not to connect them in this kind of loop fashion. Okay, well there we go. It's ugly. But basically, yeah, what we're saying here is we're saying, hey, just keep looping until you get it. Now, obviously, of course, if it doesn't get it, then that's going to be problematic because it's never going to continue. But in most cases, one loop of this is going to actually pick it up. This is something that looks and works better in code than it does in Blueprint. Let's give it a try again. Okay, so what we want to do is we want to find somewhere where we can see where the sun's at. Basically straight up in the sky. We stop it, then we hit play again, and it should go back to the same spot. And it did. Do it once more just to make sure. So, here we go. Stop. Play. And it went right back to where it was. Okay, that fixed it. We were just trying to read the value too early. I guess I got lucky when I was testing it, and I don't remember it ever not working, and I did play with it for a couple hours, so probably it had to do with the fact that I know this is it, actually. I was running against the local server. The local server is going to be far faster than running it against the server over the internet. So those timings were different, so you always got to be careful about that. Anytime you make an asynchronous call, it's a fire and forget. You have no idea when it's going to come back. There we go. Dark's pretty nice and dark. I do like that. Pretty happy with how that looks. You'll see here with the way the fog comes back in, it's a little abrupt. Again, this is 120, which is also a number you'd probably never use. So it's still way too fast. Don't think you want 122nd, but watch what happens here with the fog. It comes in just a bit, just a bit quick there. So what we can do, I feel like a good number to start with, 7,200 seconds. I want to show you how to tune this. So what you want to look for is you want to look for if you can notice these, if you can notice the sun moving. That's pretty good. So this is at a 1 second, 1 second update interval on the sun. And it's pretty good. The shadows are a little bit, if you look at the shadows there, the way they're moving, they're not great. In a production game, though, I really don't think I'd want to update faster than 1 second, 2 second, 4 second like we've got it. Could if you want. Probably wouldn't kill you. But again, 7,200 may not be, you may do longer cycles than that. So that's basically 7,200 seconds for one rotation of the sun. And we'll test it again, make sure the sun goes back to the same place. Yay! Can't really tell if it did, but it did. And then the other thing that we can do is we can go here, and so remember it was over at that edge, right? And we don't want to have to wait for the whole night cycle to reset. So what we can do is we can come in here. You know what? We need to expose that one too. Let's bring back our time of day, and let's make our test start offset exposed. And we'll go over here, test start offset. So if we do half of this, what we should get, and you can't do negative here, you always got to go forward. What we should get is that it should just be coming up in the morning. Because we basically did 180 degrees. It went from being just going down to it's actually coming up in the morning here. Watch it for a second. The sun should start to peak up. I think it comes through there. That 7,200 seconds is not going to come up quickly, but the sun had gone down. It should be peaking up above pretty quick here. If not, I'll stop it. But anyway, that is a way to make a high performance, because basically the only thing we're syncing is that time sync. We're doing it every second. We could potentially slow that down as long as we know that the server time clocks are pretty good. So we could do that less often, maybe 15, 30 seconds. And then we're really not paying much at all in the replicated area because all the work's being done client side rather than server side. There it goes. Look at it. It's peeking up over that mountain. So you can use that test offset so you can move it to wherever you want in the day. Eventually, I am going to add, it's not there yet, but I'm going to add a button for you on the management console in OWS that lets you reset it. So right now, everybody's got pre-filled. So everybody's starting cycle is sometime last night when I uploaded it. And you can look, see those shadows are still moving a little too quick. A little too quick for what I'm happy with. So, again, it just comes down to what your cycle is. 7,200, may even still be a little quick. I'm not sure what that works out to. Anyway, we can do the math and figure it out, but let's do that real quick. Calc. So, let's see. For 7,200 divided by 60, it's 120 minutes, so it's 2 hours. That's actually what we were kind of thinking of for our game, is a 2-hour cycle. So maybe some other things we have to do. Maybe shadows have to update a little bit faster. That one's not nearly as expensive, and we could potentially do something like, instead of 1 second, 2 second, 4 second, we can maybe do, half second, 2 second, 4 second. Main thing is just to make sure that 4 second one doesn't run too often. Let me show you that real quick. I'm going to do stat FPS. So what you'll see, maybe I'm hitting F11. It doesn't hit hard. You sometimes see that 11 jump up to 12. 2, 3, 4, 1, 2. It's possible that's what that blip is. But that blip could actually be something else. Also, Epic has told us that there are a lot of stuff like that you can't really rely on those numbers in the editor. One of the main ones I'll mention, because you might notice it, is how we do that huge fast worlds thing, and we have it so that we're level streaming pieces in and out. Well, we've noticed in our game, which is huge, that we get a blip, pretty noticeable, to where your system kind of locks for a second while you're anytime a new level streams in. And I was really worried about that. And what I've seen from Epic is that it's a known editor bug, and it's not an issue in the package client. So we've tested that and kind of confirmed that it's really not a big issue in the package client, as compared to it's a big issue in the editor. Okay, so there we are. I did not have to change the plugin. The plugin is good. You're good on that. Again, it was just I did something different than what I did in the test, and that's where you run into issues when things don't match. So there you go. Now you got a multiplayer day-night cycle with synchronization across server instances, and they should be good to go. Okay, until next time, see ya.